Okay, welcome to Engineering Design 1. For this lecture I wanted to talk a little bit about what is design. Design is, if we had to make a sentence about it, design is synthesizing something new, right? The important part's new. You're not designing something if you're just copying somebody else. So designing something new to satisfy a need, right? So there has to be an identifiable need, a gap in what currently exists that you are trying to fill, right? And we're going to come back to this over and over again, that this is probably the most important part of what we do as designers, right? Engineering designers. The new part comes naturally if you've done a good job of defining the need. Now this sounds pretty easy actually, but it's actually in practice it's quite difficult. But why is it difficult? And it's difficult because, well, first of all, the problems we solve are not straightforward. This class is not going to be like fluid dynamics, right? This class I taught a couple times here. You know, just about every problem we gave you ended up with what? A number with some units, right? In this class, and it was either right or wrong, or at least relatively close enough it was right. In this class, that's not the case. There are infinite number of right answers and an infinite number of wrong answers. So, you know, there's not, like I said, there's not one right answer, right? There's no answer key for this class. And that makes it very difficult because you have to, it's very easy to come up with answers as a result, right? Very easy to come up with answers. But some answers are, this is obvious, I know, are better than others, right? So you're going to be able to come up with an answer right away for this class, but you're going to have to think hard and for a long time and try to come up with better answers than the ones you got, right? And some of them are much better, right? I love this example I found on the internet. So this seems really cool right here. This design somebody came up with. It's always frustrating trying to get that last bit of toothpaste to come out of the toothpaste. What do you call those? Toothpaste tubes, right? And so what somebody did was, instead of having two separate devices, they put a slot right here into the handle of a toothbrush, and that seems cool. It seems awesome because now instead of having to buy two things, you only buy one thing. So theoretically, this is going to make somebody a lot of money, right? But the problem is how exactly do you get this stuff, which is what you want, right? How do you get it to go here without having an intermediary step where your toothpaste is on the surface of your sink, which, if it's my sink, isn't necessarily clean all the time unless somebody's coming over to visit. So this ends up being pretty bad as compared to this design, which accomplishes nearly everything this does, but does it for far cheaper because we don't need a slot there. We can just cast this much more easily. This is still a solid design, which is why you can still buy it, right? At Walgreens or something like that. So this is cool, right? But ultimately, it can't satisfy the needs of the customer, which is to be able to easily get the toothpaste onto the toothbrush bristles itself. Which brings me to the second reason why design is difficult. Second reason, which is your goal is to have a good design, right? This is remarkably difficult, actually, in practice, not a cool product, right? Not a cool product. A good design requires discipline, right? A good design requires discipline. You're going to, as part of the first part of your design process, you're going to develop needs and engineering requirements. Where needs really are things that a consumer or whoever's using your product, these are the things they would say that they need, right, out of your product. Engineering requirements are you translating these needs into numbers, essentially. Like, they say it has to be strong enough to hold up a person. Well, what does that actually mean in engineering requirements? Well, it has to hold probably 350 pounds, right? Something like that. This is what you have to satisfy, not something cool, not something that, is neat. And much of what we will learn this semester are tools to help us, I like to say this, keep our eyes on the prize, right? And what is that prize? These engineering requirements. I'm toying with this idea this semester. But for example, there will be a negative 10% penalty if you suggest titanium or carbon fiber as a material. And it doesn't clearly warrant it, right? Titanium has its uses, don't get me wrong, but not often, right? Carbon fiber is the same thing. It's very difficult to make things out of carbon fiber. It has great properties, but it's very expensive to use. So yes, we will learn lots of tools to help us keep our eyes on the prize. 3, it's also difficult because you have limited resources. And I'm not actually talking about the cost of your product or the types of materials you can use. Sure, those are limited, but honestly, that's not the most difficult part of the design process, working around those restraints. The most difficult part of the design process is that your time and money you have available as part of the design process to develop it are limited, right? They're limited. Time is your worst enemy. And not only in this class, but when you're designing products in general, right? You have, like I said before, you have an infinite number of possibilities that you have to search amongst and narrow down to find the one design. Infinite number of possibilities, but you have to find the one design that best fits your needs / requirements, right? That's remarkably difficult, right? If you had an infinite number of times, if we were all immortal, you could set up a FEA analysis of all the parts, of every possible iteration of all those parts, and test them all, and then pick the one that's the best, right? The one that uses the least material, is the strongest, is the cheapest. Fine, but you don't have that luxury, so you end up having to make decisions based on limited knowledge, and that's what's so difficult. That's a huge difficulty in the design process. But why do we have a time crunch? Why is it so important to do things so quickly? So on this axis here, I have percent of total cost to company, right? So at first, let's talk about what the design process costs to the company itself, right? So we'll do that in red. This is money spent, right? This is money spent. So at the very beginning of our design process, we start with market research, right? We start looking at the market, and our main cost is wages, right? We're paying people to do this. Maybe we're paying for some surveys, but it's not that expensive, let's be honest. Conceptual design, we have to get some more designers in to actually, again, we're just worrying about wages, office space for these people. It's not that expensive. We've only spent maybe 10% of the total cost that this product is going to cost our company at this point. Detail design, things get more expensive, right? Especially towards the end of detail design, because towards the end of detail design, and it requires more people, right? All these details that we have to nail down, material of each part, the exact dimensions of each part, how we're going to make it, how we're going to assemble it. All this requires actually quite a bit of manpower. So we've spent a lot more on wages, and towards the end of the design process, once we've figured out how we're going to make these parts, we have to start spending money on tooling, right? So this part here is all wages, right? This part here is wages, and at the very end, maybe some tooling, right? We have to start paying people to start making the machines that are going to make the things that the product that we want. Manufacturing cost goes up a lot, right? We have to pay for materials, we have to pay for the actual manufacturing process, and then as the product is used, we're going to have continuing costs such as litigation if people sue us, returns. Maybe you've guaranteed your consumer that you're going to replace things, right? So to the company, right, the beginning of the design process is actually fairly cheap. However, this is important, and this is something that matters a lot to companies. What the money is actually spent is not so important as the money that is committed, right? So what I mean by committed is how much that the company knows that they're going to have to spend. Because if they know they're going to have to spend it, they can't. It's in reserve, right? They can't spend it right away. So right off the bat in market research section, they're going to commit a ton of money, right? 30% of the total cost of the project. Well, this is rough. These are estimates. Don't. It's not like 30.12%. It's rough. But like a third of the cost of the project is committed right off the bat once you decide what problem you're going to try to tackle, right? The cost of tackling a McDonald's Happy Meal toy design is much different than designing the brakes on a commercial airplane, right? Much different. So a lot of the initial cost that you're committing is just chosen by what problem you're solving. Then, right, your conceptual design, you're deciding how you're going to solve it. Again, you're committing a large part of the cost of your product simply by deciding how you're going to solve that problem, right? General features. Let's say we're doing brakes on an airplane. How many different rotors are we going to have? Brake rotors for our disc brakes. What general materials are they going to be made out of? In detail design, we continue to commit. We actually end up committing. At this point, we've committed a significant amount of the cost because we've already decided we're doing 5 rotors and we're going to be made out of some kind of ceramic. Well, okay. what kind of ceramic does not really affect the total cost all that much. Once we've decided ceramics, we've already nailed down a lot of our manufacturing, so the committed cost is a lot less, right? And finally, during manufacturing, we're going to have tweaks to the manufacturing process, stuff like that, but we've already committed a lot of the cost because we've already decided what we're making, right? And this is all fine and good, but you want to get through this part as fast as possible, right? This is committed cost is as good as spending that money, right? So you've spent a lot of money at this point. At this point right here, before you even started the detailed design, you've spent, quote unquote, a lot of money. But when do you start actually making money as a company? Well, you don't start making money until, this part right here. Somewhere after you started manufacturing the money, this is when you actually start getting return, right? People buying your product and you get money back. So you want to get through the company. You don't want to. You want to spend as much time doing this as you can because it's fun. But your company wants you to get through this as fast as possible so they can start making money, getting the return on this investment right here, right? This is the investment and this is the return. They want to get through this as fast as possible. So, and this is the key, right? The faster you get through, oh, that's the wrong through, but you get the idea. The design process, the faster you make money. Also, the faster you get through the design process, the lower your risk is as a company, right? Because there are advantages to getting a design done quickly. You get first to market advantage, right? Sometimes. First to market advantage. A good example of this is like if you look at high-end sports equipment, right? High-end sports equipment, like the latest in I'm trying to think of what sports you would do here. Well, in bikes, for example, the first person who put out a carbon fiber race bike was able to charge a huge premium and make a ton of money on every single bike, right? And they became associated for a long time with carbon fiber bikes. Now everybody makes them, and you make much less money on each carbon fiber bike. So if you're first to the market, you can make a huge amount of profit on each of your things. Also, your name can be associated with that product, which is always good. People still buy Xerox. I mean, they call it Xeroxing instead of making a copy, it's Xeroxing because Xerox was the first to make these office copiers, if you will. So first to market advantage is huge. Also, design is an iterative process, right? The first product you make is not the best product. You're trying to get it to market quickly, so you do things in non-optimal ways, right? Let's say you're assembling it. It might be easier to just use a whole bunch of screws to put it together, even though that's very expensive. So the second time you make it, right, you spend more time now figuring out how to do snap fit parts or how to use adhesives to make the product efficiently. And so the faster you can do these iterations, the more quickly that you can change things like cheaper manufacturing and things like that. And I just said, like I said, design is iterative. It's not only do you, once you've started making a product, do you redo the product often. You'll do redesigns, if you will. But the actual design process is quite iterative, right? And the reason for this is because, like I said, time is limited. So sometimes you have to make decisions. As a result, you have to make decisions. Before you are ready. Before you feel ready. Ready? Right? And like I said, there's so many variables, so many possibilities, you'll never actually test every single possibility, right? So I don't really know what ready means in design, but you're going to have to make decisions before you feel ready, right? Before you've tested possibly every possibility that you want to test. And so what ends up happening is, first we identify our need, your needs, set down your requirements. You start doing conceptual design. In broad strokes, you try to narrow down the range of possible solutions to your problem, right? And then in theory, you go from there to embodiment design. Here, you make sure that all the functions of your product, all the problems and all the functions you need to solve those problems that you identified here and identifying the needs show up in your product. Then you theoretically go to detailed design. Right, you nail down all the dimensions and materials in order to satisfy your engineering requirements. Here you say it has to be a certain strength, so we're going to have a beam here. Now you nail down the dimensions of that I-beam and the material you use. And then finally you go into production, right? However, because you're doing things as quickly as possible, you get into embodiment design and you realize that this conceptual design that you chose can't quite get all the features that you want, so you have to go back to conceptual design. Maybe you go back through embodiment design, you get to the detailed design, and you realize, well, a beam isn't going to work here, we have to use some kind of truss system, so you go back to the conceptual design or back to the embodiment design. You're constantly going back to fix things and change things, because as you move through this process, you continually get more information, right? And as you get new information, it's okay to go back and change the decisions that you made before, right? In fact, you kind of want to if you can. Sometimes you can't. Sometimes it's too expensive. Sometimes you've gotten to detailed design. You've decided you're going to mill this part, so you've told the manufacturing that they're going to need to set up some milling machines to do this. They've spent $50,000 setting up these milling machines. It's too late at that point to go back and change your design, maybe. So you can't do it. But if you can, you do. You go back and you change things as new information comes up, right? As new information comes up. So this part of this process is what we're going to cover in this class, right? And theoretically, this is what you cover in the second semester of this class. However, as I pointed out, it's not as clean as splitting it up right here, right? There's no clean split here. Next semester, you're going to start making stuff. You're going to realize, oh man, this is impossible to make. We're going to have to go back and we're going to have to change our maybe our embodiment of our design, maybe our details of our design. Like you're going to put it together and something's going to fail. Clearly, you're going to have to change the details of the design. This strut's going to have to be a little bit thicker. Maybe it's not going to do exactly what you want to do. You're going to have to change the geometry of your design. It's not powerful enough. You're going to have to change your motor. You're going to have to change all kinds of stuff. So, like I said, theoretically, this semester is everything in this direction. Next semester is this, but in practice, you're going to go back and forth. And actually, this nowadays is a lot easier than it used to be, right? You're going to put stuff. You're going to create CAD models, obviously, of your design, solid models of your design. And because nowadays we use parametric modeling software, it's much easier to go back and change a few features of your design than it used to be, right? You used to have a design, you used to draw it. There are teams of drafters in engineering firms who would draw things up, and changing a design meant you had to go back and actually change the drawings, see what those changes would make. It was very expensive. Nowadays, though, we're very comfortable with going back and forth between all these different steps. Okay, so our next lecture, I'm going to talk a little bit more about what design is, about the details of what design is. Yes.